Okay. So we'll get started on time here. I'm Paul Coggin, Dynetics out of Huntsville, Alabama. I'm a network guy. My background is design, implementation, securing, and figuring out how to break into network infrastructure for various organizations. We'll just leave it at that. So we have when I work on a red team, going out doing pen testing for organizations, I'm the network guy on the team. It figures out how to get into the network infrastructure. And so I'm going to go into some details on some less things I've learned working with red teams. When we'd get shells into routers, the red teams wouldn't know what to do. So I've come up with some ideas of what you can do. So how could you maybe get a shell to a router? One way that you might get that initial handhold, just to give you an idea of what you could get that initial remote access into the router, is there's a tool called SNMP below you might use. You've developed a dictionary attack or a dictionary of SNMP community string keywords, kind of like a password list. You could use SNMP below and use your SNMP community strings that you've compiled. And if you've learned what the trusted host is for monitoring and managing the network, you can feed that into this SNMP below script and specify the network management IP that's trusted by the routers and switches, because we're assuming that these routers and switches have been secured and there's an access list that is controlling and limiting what devices can touch SNMP on these devices. And then you can specify the IP address of the network device that you want to go after and specify the IP address that you're using to attack the system with that you want to TFTP download the config file to once this script runs through your community string list and finds a good community string, it's going to download that to the attacker system. And the reason that's going to work is SNMP uses UDP. The access lists are going to be set up to block anyone except for the trusted host from connecting to the network devices. And so you're going to have a very, very hard time, if you could even pull it off, getting a TCP connection going, because of the three-way handshake is going to be blocked. But with UDP, it's fire and forget. With UDP, you can just spike packets down the wire. And so that's what this script will do, is just fire UDP packets, testing for SNMP community strings, and when you find a good community string, it will go and trigger the router or switch to download your targeted router config or switch config. Then you can go and learn the configuration and learn lots of things about how the network is configured, routing protocols, etc. And then based on the information you have, then you could go and push up a new config because you've guessed the correct SNMP community string, and it's just a UDP. You can spike up a new config using a new SNMP command and take over the network and spread influence. And so what I'm going to show you now, we're going to get into a number of scenarios. So we've gained access to a router, maybe using something like this. Maybe you've one of the web guys on the team is got you into a directory, and you say you're in the TFTP directory by way of some kind of web hack. Maybe you popped JBoss and got a shell, and you're in the TFTP directory where configs are archived, and you may come in through that way and get access to the network infrastructure. So what can you do to elevate privilege and do some cool tricks with the routers? Well, I started thinking about this. I was in a very large red team engagement with a lot of world-class hackers, and they're popping shells everywhere and got hold of the network infrastructure and didn't really know a whole lot about what to do with it. And so it made me come up with some ideas here. So here's some things you could do. If you get access to a router, and I'm a Cisco guy, and what this is going to get into is what I know about Cisco routers. There's a capability called policy routing that is enabled by route maps, and you can go and specify access list. An access list is going to specify the traffic that is of interest to you, because if you try to do this attack, you want to get very, very granular and go after certain types of traffic, because you wouldn't want to go and have a wide open attack doing this method, because when you do the policy routing, it's going to be CPU process based. It's not going to be switched in ASICs. So you don't want the network to take a performance hit and possibly be discovered. So you've got access to the router. You turn on route maps, enable it on key interfaces. And what you could do is when you do the policy routing and set up the route maps, it's going to enable you to override the IP routing table on the router. The routing table may tell traffic to go northbound, but you know that you're on this layer 3 switch. It's got all these VLANs, and you want to do a man-in-the-middle attack, but you can't do the man-in-the-middle attack because the traffic that you want to catch is going inter VLAN, and it's not just inside of a VLAN where, if it was intra VLAN inside of, say, VLAN 4 here, you might be able to go and do your ARP poison man-in-the-middle attack, but by using route maps and reconfiguring the router with route maps on whatever VLANs you want to attack, you can set up a layer 3 man-in-the-middle attack inter VLAN so that you can capture traffic, override the routing table, direct traffic to the host where you're monitoring, where you want to capture passwords and other interesting information. And after you've captured that password, then you can forward the traffic back to the routing table, and the traffic flows on like it normally would. Another scenario that you might use is if there's traffic that you want to exfil and you don't want to go out to, say, the perimeter edge network, because they maybe have visualization instrumentation on the network that is looking for traffic to leave through the perimeter, because that's where everybody puts all their capabilities at the perimeter. Well, what if you got some kind of mobile 3G, 4G router backdoor into the network? If you got access to that router, you could override the routing table for the traffic that you want to exfil and force it out that back door, and the routing table will forward all the other traffic just as normal. They'll be collecting their logs up at the perimeter, and they'll never see your traffic that's going out a back door because you're overriding the routing table. Another scenario, this is going to be a very more sophisticated actor. This would probably be a nation state that would probably do this to you. You'd have to be an important organization. This would be somebody who, up at the top perimeter where you're multi-home to the internet, you got multiple BGP connections, and someone who is targeting you has access to a data center. They know your BGP, they know your routes, they know how you do B2B, etc. And maybe they have better access into a certain data center, a certain telco upstream service provider, and they would want to go override your internet routing and force certain traffic of interest out another specific northbound connection where they can do more things to your traffic that you may not be aware of. Depending on the organization, this is something I might do to them during a red team, depending on the rules of engagement and how they're architected. But this is something that's overlooked in a lot of red team engagements, is overriding the routing table to do what you want to do. Now, this is some old school stuff. If you've been around the pen test world for a long time, you know about, especially if you're a network engineer, you know about doing GRE tunneling. We used to do GRE tunneling back in the day when I got into networking to backhaul legacy protocols like IPX, DECnet, LAT, AppleTalk. We'd backhaul that, tunnel across an IP network. Today you might tunnel IP over IP and encrypt your GRE tunnel. And it's published here at this reference. There's a really good paper on this method for combining a route map that I just described to you. Combining this GRE tunnel, so if you pop the router, you get access to a target's router, you can go and use the route map, build the GRE tunnel, and redirect traffic over that tunnel so that you can sniff the traffic. And this is pretty well documented. But another technique that is available to you today, similarly, is ER-span. In ER-span, if you're familiar with switching and doing port mirroring, you know about doing port mirroring on a local switch or doing R-span, switch to switch. Well, there's another capability. If you're involved with a red team engagement, you might want to take advantage of, is do an ER-span where you can do a port mirror across a wide area network from a remote site over, say, a T1, T3, whatever network connection the customer has that you're going after. The only thing with this is you're going to capture a great deal of traffic. Where I would probably use this, and I plan to use it in the future, is going to be in a critical infrastructure network scenario where maybe a SCADA network, it's not going to be a great deal of traffic, and I can go and do this ER-span and mirror off and pop out to a remote VPN connection across a wide area network, across the internet, SCADA traffic or other interesting traffic. If you get into a highly utilized enterprise VLAN, you may end up generating performance problems on the network and get discovered if you do this to the wrong network. But it's another method technique to exfil traffic that might be useful. Well, back when I got into routing real heavy back in the late 90s, I discovered, I got involved with a project building a large wide area network across the country from Alaska to Miami to run SNA back to a headquarters site, actually 2 headquarters sites for green screen terminals. And what we would do is we had to backhaul SNA SDLC protocol over IP back to an AS400. And I discovered this protocol called DLSW that allows you to tunnel. According to the RFCs, it is designed to tunnel NetBIOS and SNA. And the way things work with the routers is if you turn on routing, whatever protocol you've turned on routing for, when the router sees it, it's going to route it. But if you also turn on bridging and you have routing turned on, and additional protocols hit that router, say hit the router interface that has got bridging turned on at the same time routing's turned on, if routing's turned on, it will route, but if bridging's turned on, it will bridge it. And so that got me thinking. IPv6. IPv6 is a routed protocol, but IPv4 and IPv6 are totally different protocols. At layer 3, they're totally different. Layer 2 is the same. Layer 4 through 7 is the same, but layer 3 is different. The router sees them different, and you have to manually go in and turn on IPv6 routing if you want it on. Most of the networks don't have IPv6 turned on, especially on the inside, internal networks. So come up with, this is an undocumented capability. I talked to Scott Hogg, who actually wrote the book for IPv6 security for Cisco Press. I threw this out at him at Hacker Halted last year. He thought it was a cool idea as well. But you can, because you got IPv4 turned on and routed, and you can turn on DLSW, which will tunnel. And part of the configuration you see here is bridging. It'll bridge anything that is not routed. We could maybe, if we pop a router during a red team and they have the feature set code, they may already have it turned on. We can turn on DLSW and maybe set up a backdoor tunnel and tunnel IPv6 out using DLSW. There's still a lot of this SNA stuff out there, and there's a lot of routers out there that have the DLSW feature set. Now, this is not something that is supported, but it's a capability. It's the whole thing about hacking is making things do what they were not expected to do. So this is a method and technique you might want to do in a pen test with it. If you get a hold of a router, like I said, to exfil IPv6, use IPv6 for pivoting and tunnel back over the network. A lot of my background since 2000, I've been in the telco service provider, utility, critical infrastructure world, building telephone companies, going from analog digital to pure IP over Ethernet networks across the country. And in that, I learned about a protocol called L2TPv3. I'd never heard of it when I was doing enterprise stuff. But what L2TPv3 does is it allows you to logically drag and drop what we call a pseudo wire from one Ethernet router interface across X number of routers and drop out that VLAN off at another router somewhere in the world. And it doesn't matter how many routers you go across. You can basically drag a VLAN. Think of it as dragging a layer 2 tunnel across the routed network. Now, how the reason that was created, the reason the IETF, IEEE come up with this was people like AOL will use it to backhaul PPOE from, say, your DSL modem. They don't own your local loop, say here in Nashville. AOL doesn't own the Bell South copper lines, but what they could do is they go wholesale lease copper to your house and sell you AOL DSL service, and they'll backhaul your PPOE connection back to their router, and they call their router a BRAS, a broadband remote access server. That's just marketing for a router. and they would aggregate that L2TPV connection and terminate your layer 2 PPPoE that has been running across X number of routers. Now, the whole point of this is you can go and what I want you to get is you can create this layer 2 connection across all these routers. And the beauty about layer 2 is very few organizations, at least when I'm involved, the red team engagement or doing a network architecture audit, very few people pay any attention to layer 2 security. So if you can get access to the router and you can enable this layer 2 connection back to your network, what's to stop you from going and raking all kinds of havoc? If you're not aware of a tool called Yersinia, it's wonderful at layer 2. You can really do some damage. Yeah. Totally different. Totally different. OTV is more of a data center. The L2 TPv3 is a totally different protocol. So this is something that you might use in an engagement. What I have seen documented and published regarding L2 TPv3 is attacking the control plane of L2 TPv3 in the telco infrastructure. There's a good paper if you're interested in L2 TPv3. There's a good paper about from a telco standpoint if you're in the cloud attacking it. But this I want you to look at it from, say if you're in a typical enterprise red team and you pop somebody's enterprise router, they probably got the feature set that you could turn on this L2 TPv3 and shoot a layer 2 tunnel right out their internet router. Because, I mean, how many firewalls have you seen configured to filter outbound? They're just waiting for you. They're just waiting for you to turn on its own, and you should do it because you can. I mean, you got to do it. It's good. Now, here's something else coming from the telco world. All of my customers in the service provider business have to be able to provide support CALIA, think Patriot Act, and basically an IP-based wiretap when the government comes in and serves them a subpoena that they want to go and monitor somebody's network. They get fined daily. I forgot what the amount of the fine is. Every day that they cannot provide this lawful intercept capability to law enforcement, they get fined every day. And so they have the ability on their network to be able to do an IP-based wiretap. And that takes advantage of SNMPv3 in the network infrastructure. SNMPv3 is what enables the core capability of lawful intercept. Now, how they know that they're going after the right person when they do the IP-based wiretap is one way would be doing PPoE with AAA radius authentication so that your username authentication is associated with the IP address that you're handed out by radius. Another way, if they're doing DHCP, and the reason I threw this up here is a lot of enterprise guys don't want to do DHCP because they think they can't track an IP address down to a user and attribute different activities on the network. But what you can do, and what we do in the telco world, you can do this in the enterprise, is you can turn on DHCP snooping, and if your DHCP server supports option 82, what happens is when you do DHCP snooping out at your edge device, your access layer, when that network device sees that DHCP request, it injects into the header the name of the chassis and the physical port interface number as it heads northbound. And if your DHCP server supports option 82, it will log that. So if you start having an IP address that's acting interesting on your network, and you're a DHCP network, you can nail down and attribute it at this time, this user, somebody was sitting in this queue or coming in from this wireless access device, because you've got the DHCP logs to prove it, so that you can go in and do root cause forensics, incident handling. So wanted to throw that out there. All the telco gear supports this because you don't want to go do a wiretap and kick in the wrong door, though that happens. Apparently, but that got me thinking. You pop a router, you get access to somebody's router. They may not be a telco, but if they have the memory, if they have the flash, if they have the DRAM to run the code, and you've got a hold of their router, here's the thing that I've learned. If you can hack their router, they are not going to know, most likely, that you've upgraded their code, so that if they don't have the feature set, There's nothing to stop you from uploading their code. And the reason you'd want to do this lawful intercept is you and I could be talking, and with the lawful intercept, a perfect copy is going to the attacker system. Now, typically, it's law enforcement is getting a perfect copy, and the two people talking do not know that they're talking. You'd have to do it on your interfaces. But it'd be real quick. Just if you're a Cisco guy, use a range command, and you could do like on a fully populated 6509, do all your 384 interfaces. You could do it with one command, practically, with just using the interface range command, hit all your ports. But this is something you could do if you get into the router. They may have a feature set already there that enables the lawful intercept. If they don't, put one on there for them. My experience is when we get into somebody's router, they don't know that we're in their router till after we're giving them PowerPoint. We're doing a briefing, and there's been an outbrief, and they're like, "You're in my router? You've been in my router how long?" And we have to go and start showing them dates and things. So this is something else to go do. Just another cool way to go and do exfil. And if you're a defender, one of the things I want you to take out of this, you better be monitoring what you let leave your network. Because if a redneck from Alabama is thinking about this, you think about somebody who's got real skills and real knowledge, and real evil intentions, what they could do with your network and your data. You gotta block that outbound traffic. Very rarely do we see the outbound traffic being blocked, but hey, something somebody could do with those routers. And the other thing is when you go in and you do your root cause forensics, you get popped, you get hit with some malware, and somebody's in your network. The other thing we're seeing is everybody's looking at the endpoint devices. Nobody's looking at the network infrastructure. Better go look at that network infrastructure because the bad guys may be in that. So here's a scenario. Another idea for routing. You got this scenario. You got a cable TV head-in. Got a utility. A lot of the telco service providers are getting into the cable TV business, basically IPTV. Over Ethernet, and what they do is they're mapping TV channels to IP multicast groups. So when you hit your clicker at home, you're not changing an RF channel over the cable hybrid fiber coax network. You're actually changing an IP multicast group every time you hit the clicker. And what some of these guys will do is there's organizations that will go and make the big capital investment in the IPTV infrastructure and then resell their capability to other networks. They want to minimize their investment, so instead of having to buy out a full-blown IPTV head-in, they can just go and buy enough equipment to, say, pull the local off-air channels, and then all the other channels they can pull from a cloud-based service. Typically, it's going to be over a fiber Ethernet. And what happens though with multicast is you see up here on the right, you see that black line pointing back to the cloud. With multicast, there's a rule called reverse path forward. And these servers are going to be, in the network infrastructure over here in this, and the right is going to be pulling multicast. It's going to be receiving multicast from that managed service provider network. And then it's going to forward it out to the customer network down there in the bottom. Well, that IPTV head-in infrastructure on the right is not going to forward that traffic because of the reverse path forward rule if it does not have a route in its routing table pointing back to that cable head end. And so a security mitigation, both a way to make the multicast work and a security mitigation, if you're an IP network guy, you'll get this, is the default route points back toward the cloud, because the multicast is going to receive the stream from the cloud, and then it's going to shoot it back out toward the distribution network, the customer distribution network where your subscribers are. And it doesn't need a unicast two-way connection. It's just going to shoot it toward this network infrastructure here. It's just going to multicast it out, and then this network infrastructure will pick up that multicast stream and shoot it back out into the head-end. Now, here's the challenge from a red team standpoint. You're coming in from the outside, and you find yourself on this network box here, and you might have Visio diagrams. You've social engineered somebody. You've spear fished them. You've popped into their network. You got Visios. You know how this thing's architected. You know IP addresses. You know they're running some old Solaris stuff. And you know with like 2 commands, you're going to have root. You're going to own this network. You're going to pivot all day. It's going to be screenshot heaven. But you got on that router and you can't get that 2-way connection. You're looking at the drawings. You got the goods. You know how this networks. You don't even need Metasploit. You got the passwords, but you can't get a 2-way connection in. What I discovered in a similar scenario is if you can get this access and you start looking at this router and you start looking at the ART table and you see the MAC address, IP address mappings, and you're looking at those OUIDs, and you know you got some good stuff. You got some Solaris boxes, and whenever I see Solaris, I think old, unpatched boxes. When I see Solaris, it's low-hanging fruit. It ain't up to date, because with this type of stuff, with this critical infrastructure, you get it working, and you leave it alone until you retire or somebody forces a major upgrade. That's how it works real world. But what you can do is once you start finding these boxes in your ART table here, is you could set up a static NAT. You set up a static NAT from the interface where you have connectivity here. Right here, you set up that static NAT here and point back to whatever you see, what you want to go after first based on MAC address, organizational IDs you've identified. Set up that static NAT. Now, what we discovered in Red Team, a little trick, is the router will proxy ART for you and allow you to have that 2-way connection. And then you can start spreading influence and popping boxes using username password that you might have gotten through spear phishing attacks or pop out Metasploit if that's what you need to do. But that's a way to twist the network to do what you need it to do. So OSPF, I want to go over this real quick because I see this everywhere when we do Red Team. So here's how OSPF works. OSPF is a interior gateway routing protocol, IGP. If an organization is running a routing protocol, 9 times out of 10, it's going to be OSPF or maybe EIGRP. And with OSPF, you've got to have an area 0. And if you're a large enough network, you may break up and segment your network into other areas. So you might have an area 1, area 2, to break up and segment the network because of the size of the network. And you got routers that tie the areas together. They're called area border routers. And if you've got if you tie into other external networks, it's going to be called an ASBR, where your router may tie into, say, an EIGRP, an ISIS, BGP. You really don't see ISIS too much. ISIS you're going to see mostly in a telco world, specifically a very large telco world that's running MPLS. So this is what you're going to see, but the thing I want you to get is, the reason I bring this up is wherever I plug into the network and OSPF is being used, it's just waiting for somebody to go and pop, because the OSPF is going to support no authentication, clear text authentication, and MD5 authentication, and for the freaking love, if you understand you need authentication, why do you go and enable clear text when MD5 is an option? I mean, if you have enough sense to turn on authentication, if you have that much understanding, but nobody does. They'll turn on authentication, but it's clear text. So all you do is fire up Wireshark, and you see all the multicast of the OSPF, and it may be that's not authenticated. You'll see it all out there on the wire, or you'll see the clear text password, and 9 times out of 10, it's some project-related name, SCADA, Cisco, whatever, name of the company, and it's sitting there just passing on the wire in clear text. And so what can you do with that? Well, depending on your rules of engagement, you're doing a Red Team, you guys are all ethical guys and ladies. When y'all are out doing a pen test, you want to make sure your rules of engagement are going to let you go do this. Here's some ideas for you. Why not go and inject routes? Very, very easy. You could use Quagga, a tool that you need to know about if you're interested in networking. You want to learn routing protocols and you're vendor neutral. You just want to know protocols because you're security type. Check out Naval Research Lab Core, the network simulator Core. It allows you to fire up a bunch of Quagga routers in a nice virtual environment. You can download a VM all set up with Core ready to rock, and you can run OSPF and BGP, and you can join the network and start injecting routes. And with that, say with that NRL environment, you could go and draw out a large convoluted network and start injecting all kinds of routes into the network that you have access to. And let's say you start injecting routes for, say, NSA, DHS, China, France, Russia, and if they've got logging, they got their SIEM system. All the cool kids got a SIEM system now, and they're logging. They'll think they're under attack. And if you got this level of access, they're not going to know and realize it that you're injecting this from inside. You could totally distract them and get them running to their perimeter, trying to troubleshoot and figure out why, say, Microsoft or Google is attacking them, and fill their logs up while you're going and doing your real hardcore testing, and distract them from the rest of the pen test team, by spoofing IPs, and injecting in. And even there's this long list of tools that I gave you there. Like I said, you can add new routes. You could do a DOS. When I do red teams, my rules of engagement never allow me to do denial of service. Some of you guys may work for organizations that get to do that. We just never get to do denial of service. But it's something that you should account for in your reports. I like to do an attack tree to communicate to a customer. This is what we did. This is what we wanted to do, and color code on the attack trees where we stopped, whether it was a lack of a capability, time, or rules of engagement. But if circumstances permitted, this is what we would have done. So you could draw out an attack tree and tell the customer, hey, we would have done the DOS, and this is how we would have executed it. Maybe prove it to them in a lab. Maybe prove it with this Naval Research Lab core tool. Mock up their network and simulate it and show them this is how it would have been easily went down. And if you're a really good coder, you might roll your own OSPF tool with Scapy. And if you're Windows impaired like me, there's a tool from the Chinese called Colosoft. I think you got to get CAPTCHA now, but you could go and take Wireshark and capture these OSPF packets you're seeing on the wire and import them into Colosoft CAPTCHA into one of their tool options called Packet Builder. Pull that in and go in and edit any field in the IP packet. Make the changes you want. Rebuild the checksum and point and click with Windows. Fire those packets right back out on the wire and act like a Juniper or Cisco router, and influence their network. Just point and click. BGP has been in the news a lot lately, so I wanted to go over BGP with you guys from a routing standpoint. A lot of red teams don't get into this, but I wanted to make you aware of it as a defender, and if it is in your scope, have the conversation with some of you guys on the red teams that might be able to do this. With BGP, if you're an organization that is multi-home to the internet, if you're multi-home, you're going to be doing BGP. You may be a huge conglomerate that has BGP running in your network because you're so large, but typically you're going to be a multi-home organization to the internet, and you have to go to ARIN and get an AS number, and in that case you would also have your own independent routable IP prefixes. But this is how things work. All the organizations that have that have a unique number. Your telco service provider has an autonomous system number. And if you were to go and exchange BGP routes to the internet, you would have to go to ARIN here in the U.S. To get an AS number. And you would get your routes. You would advertise the routes that you own up to your upstream providers. And in the U.S., the culture is your upstream providers, they know you're a great guy, and they know you're the smartest router guy ever. And you may have every CCIE, Juniper certification you can get. You've got them all. They don't care. They're not trusting you. They're filtering everything you send north. They go check ARIN and they verify that you own the IP blocks that you say you own, and they filter your outbound connection to keep you from introducing loops or hijacking routes. In the U.S., we have a very strong culture in the service provider networks to protect our network infrastructure. These guys are very, very, very strict. You get outside the U.S., it's the wild, wild west. But one of the things I wanted to call your attention is you get into some of these central offices. The cool term today is all the marketing is around data center. In the telco world, they call it a central office. In the cable world, they call it a head end. And now all the cool kids are calling it a data center. Well, what'll happen is wherever this might be going on, it may be that lots of the organizations that are participating in, say, in a region, are pulling their fiber into a local spot, and they'll do a layer 2 cross connect. It may be a big Cisco switch, it might be a big Brocade switch, Juniper, what have you, and basically make layer 2 VLAN connections and join together and exchange BGP routes. What I've seen, I've been in some of these central offices where they got guards, gates, and guns, cameras, very, very strict control, access. Everybody's locked. Everybody's racks are locked up tight, monitored, alarmed. If a rack gets opened up, alarms go off. Very strict monitoring. I've been in it some places. I won't say where it was. Somewhere here in let's say the southeast. Literally, lots of organizations coming together in this central pot. Literally cabling just strode out over the floor. You had to walk across it. I mean, just bundles of cabling just coming out of the backs of the racks. Fiber is a bloody mess, and you got all these organizations that are tied together. And at these points, how hard would it be to go in and make your own cross connects into some of these networks where they don't have that mind for attention? You don't want to know who was in that CO because I wear many hats. Sometimes I'm a telco engineer building out one of these networks. Sometimes I'm a security guy, and I'm curious and I'm learning, and I want to go do another presentation. So I take mental notes and I look and see what's labeled. You don't want to know what all's in there, and it's all about that trust relationship. And they may have things locked down locally, but physical access rules. And what I want you to gather is physical access rules. And if they got that kind of sloppy attention where there's cabling and fiber going everywhere, and you don't get to see that as an enterprise customer, you got to be in the telco, working the old cloud, the original cloud, to see this and know their sins. That's not perfect and pristine everywhere. What could happen? Well, it's a layer 2 connection. If you can get access in there, physical, or if you could go and break into it logically, or both, you could go pull out the old school stuff, the old layer 2 attacks. You could inject routes. You could do the maybe pop the router and do the ER span that I showed you. Maybe go and enable the lawful intercept or some other kind of tunnels back to other organizations. All that layer 2 stuff may be available to you. You could maybe do that L2TPv3 and drag and drop a layer 2 connection across the whole internet to someplace interesting in Southeast Asia, maybe, depending on who you're working for. So this is happening a great deal. This BGP hijacking. Got an extra line here, but basically you got AS4 and AS6, two organizations that are sending traffic between each other. You have somebody out here in this, somewhere in the world, in this autonomous system 5. They just decide that they're going to target your traffic. They can start advertising your IP prefixes like they own it. And they may not be able to capture all of your network traffic, but a large percentage of the traffic of certain parts of the world where they have a better peering point, closer peering point than you do, they could redirect traffic through their network that would originally be destined to you. And if you're not encrypting it, they've got it. They're sniffing it whether you're encrypting it or not. But if you're not, they don't have to break your encryption. They can just see everything that you have passing on the wire. And this has happened in a great deal. Don't raise your hand. People don't need to know your business. But I'm going to ask you this. You need to ask yourself, are you monitoring your IP prefixes? You got your firewalls, you got VPNs, you got SIEM, you got your security awareness program, you're doing pen testing quarterly. You're monitoring, you got configuration management and control, you're monitoring everything. Nothing happens on your network without you knowing. You pay Martin to come in every quarter to hack you and test your network telemetry to make sure you're watching. But are you watching the wide area network when it leaves you? Are you looking for a macro level attack at the internet level beyond where you have control? This is happening right now, and organizations are not monitoring and looking for it. If you're not using BGP Mon, or I think it's called Renesas, is another company that will monitor network. There's another one called Team Cymru. If you're not using one of those services to monitor your IP prefixes, how do you know that your traffic on the global internet is not being hijacked? How do you know? If you're not looking, who's looking for you? And there's a lot of people that are not monitoring this today, and their traffic's being captured. And so another thing along those same lines, because of the trust relationship in the internet, there's nothing to stop somebody from not only hijacking your IP prefixes, but also hijacking your AES number in some other part of the world, and injecting that into the network and acting like your IP prefixes, because one of your business partners, they may be in the know about BGP hijacking, and so what they might do is they may be doing some light monitoring, and they will be looking for your IP address block, maybe to becoming advertised by another AS that's not you. So if I'm coming after your network, if I've got the resources and the access to the telco infrastructure to launch this attack, I've got the trust relationships, I would go and not only steal your IP prefixes, but I'd steal your AES number at the same time to launch this attack. Something that's got to be monitored and looked at. Now, another train of thought along this is I put this presentation together. I'm going to talk about this at BSides Nashville next month. Here's how this infrastructure works. When a lot of the service providers are rolling out these routers, we call them BFRs, big freaking routers, because they're huge. They're big as that door. Running 10, 40, now they're talking 100 gig. When you put those routers in place, what you can do is you can run a protocol called MPLS, and you can carve up that router into logical routers, so that all your customers have their own routing table, and it's one router logically carved up, and it's all like ships in the night. We're all riding the same physical pipe, but logically we're all carved up and separate, and we don't see each other. It's like a frame relay ATM network, but it's happening over IP. And across that same network, you could have, wide area MPLS VPN connections. You could have Metro Ethernet type connections being layer 2 tunnels being run across it, BGP. Whoever is doing these BGP attacks, the point I want to give you, in certain cases, it's probably the same people have not only access to the BGP router, but they have access to your BGP VPNs. Now, if you're a small organization and you don't have international connections, you don't have wide area network connections dropping off and all over the world, may not be an issue for you. But if you're part of today or in your future job, if you're part of a international conglomerate that is buying MPLS services, I want to strongly impress upon you to use VPN, whatever the strongest VPN you can use because of the ITAR laws, whatever the strongest VPN you can use in your remote country sites, you need to be using, because whoever's doing all this BGP hijacking, there's nothing out in the open source saying this is happening, but I believe it's going to be published at any time. Somebody's going to start talking about it, that, hey, I'm seeing new routes injected into my network via MPLS VPNs, because if I have that access, what is to stop me from going and configuring the router and joining your MPLS VPNs? I mean, I'm the router guy. I own your telco router. There's nothing for me to go and provision new VPNs into your network. Who knows or they might be just capturing and sniffing traffic. So I want to strongly impress on you for the BGP attack and for the MPLS attack that I'm speculating is happening. It just hasn't been disclosed yet. You need to be doing encryption everywhere. A lot of people say if they see the MPLS VPN, they automatically assume VPN means encryption. VPN does not mean encryption. A VLAN could be a VPN, technically. So you use encryption. Well, you would. There's an organization called BGP is one. You can. There's a company called Renesas that would go out and proactively on your behalf, as a service, monitor your prefixes. There's BGP Looking Glass servers. Go and look up BGP Looking Glass out on the web, and you could go out to different routers around the world, log into those routers. They give you a read-only access, and you could go and baseline. Here's how my network prefixes look in different parts of the world today, and baseline that. And if you got some coding skills, you might write some scripts to automate to go out to these BGP Looking Glass sites, log in and look at your prefixes time to time, and do a difference and see what's going on with your network telemetry from that internet macro layer. You could do your own, or you could get it as a service. From the MPLS side, you got to use encryption to protect your privacy. But what I'd also do, because depending on who's coming after you, if they start wanting to inject routes and join your MPLS VPNs, you need to be monitoring you need to have NetFlow and watching your internal. I'm a huge believer in NetFlow, looking at who's talking to who, when, where, and how much, and when did the conversation start and end. Be logging that, and also logging routing changes. And filter at those edges. Filter the routes that are coming into your network. Don't just leave the trust relationships wide open, and trust what's coming into you. Filter it and log and look for changes. Any more questions? I mean, lots of. It depends. I'm hour to hour. Any given day, I'm in lots of interesting places. Well, the telcos do anti-spoofing, but but when you start going and talking about going to other parts of the world with this BGP and the MPLS, I mean, you're going out and getting into the scenarios. You're getting it out into international networks. You're getting to the macro layer, and the organization is coming against you. They've got control. So you'd want to have anti-spoofing happening, and you'd want to have those filters set up, say inside for your MPLS VPNs. But if somebody's wanting to capture your traffic out in the world, there's just a big trust relationship. That's the way BGP works. There's a guy named, if you want to know more about the BGP, there's a book called Internet Routing Architectures by a gentleman named Halaby. It's like the Bible on BGP. I mean, it's all BGP is all about trust relationships. Now there's some movements to secure it, but it's going to take years before anything is implemented to truly secure the trust relationship on the internet. Any more questions? If you want the slides, you can email me. I'll give you the slides. I'll send you the new slides I'm working on for BSides Nashville that's going to go deeper into MPLS. If you're interested in that as well. And if I owned a network, I'm a consultant. I go out and build them and help people with them. But if I owned the network, I would be monitoring my partners, my business partners, my B2B partners. I'd be monitoring not only my IP prefixes, but I'd be monitoring theirs. Because if I'm coming after you, I may go and attack your partner, exploit your partner to get that trust relationship to pivot to come back into your network. Now, as a good guy, my rules of engagement are not going to probably permit me to go and, say, attack the billing system vendor so that I can pivot to come back into a critical infrastructure organization. But the bad guys don't have a rules of engagement. They do what they want to do. And so I would not only monitor my stuff, I would monitor my customers and peers that have a trust relationship with me. I'm just paranoid like that. I think I'm probably out of time. You got any more questions? Mm-hmm. Yeah, yeah. Uh, yeah, you're talking about this this list here. This what I wanted to give you is just some list of protocol tools that you can manipulate protocols with. I mean, like you can go buy a router off eBay, and the reason you're going to do that is you want the router code so that you can fire it up in Dynamips or GSN3 and join the network and start injecting routes. It's not hard to do it, or you could do Loki. I don't care about tools. I lost it when I got into hacking. I was all about tools. I wanted to go to the conferences and get the tools, go to the training, come home with the CDs. But what I learned now, I don't care anything about that. If I can Google it, I don't care. I'll Google it when I figure out what the problem is. I'm going to go, whatever the hammer is I want to use against you, I'll go and figure out how to do it. We're either going to write some code, or we'll go use somebody's tool. I'm totally agnostic. I don't get caught up on that anymore. But here's some ways that are already available to you to go attack it, and you don't have to have a lot of sophisticated skills to do it. But I really go check out this Naval Research Lab core if you're interested in learning routing or want to know about this is a tool that yes, it's free. Well, yeah, you paid for it as a taxpayer. You funded it. It's a government funded project, and it's free to download. You can download a VM, a Linux VM with this already working in it, and it works really well. And like this BGP stuff, if you want to learn these BGP hacks I threw out at you, you can fire it up. You can run BGP, you can run OSPF, you can run RIP, and you can teach yourself this stuff. It's a great learning environment. I'm thinking about doing a presentation around using it to go and do these network attacks, so you can learn it in a safe environment on your VM at home. Any other questions? Yeah. How many of those do you think is just screw up by the telco? How many of those do you think were that? Thinking about what I can say. Here's my opinion. I've been working in the telco world since 99, 2000, and there's a culture. Router guys are like Unix guys. Unix guys are very deliberate. They're very precise. When they hit return, if you're an experienced Unix guy, you know what you're doing and you know what's happening under the hood when you hit return. The guys who have access to configure the routers have control of hitting return on these global internet routers. They know what they're doing, or they would not have been given permission to do it. You don't give some rookie kid enable access to your router. Doesn't happen. That's based on my experience of setting it on. People say it's accident. Okay. Whatever. Just the other day, I was looking, I think it was Renesas, I was looking on their website. Indonesia, there is some stuff out of Indonesia where they accidentally hijacked the whole internet. Accidentally. It did not propagate out because their upstream providers were filtering them. But Akamai, a group of their prefixes, did make it out and hijack some of their traffic. But I'm very judgmental being in this business, and my experience with being in the cloud and knowing who has access to the routers and how things are done, the culture, man. Unit, like, just think about it, like with the Unix guys, when they hit return, they know what they're doing. They know why. The experienced sysadmin, those router guys are the same way. Very deliberate, and they have very strict configuration control and review. We're going to make these changes. I don't know. I'm sure there's real accidents, but we're seeing lots of interesting things, like traffic going to Belarus and Iceland, and so I don't trust anybody, and just based on what I know of staying working all night with telcos from all the large international telcos of how strict configuration control they run. When you start seeing all these IP blocks getting hijacked and things, I'm very judgmental based on that people don't get access like that, and if they're doing it, then there's major operational problems. I don't know. But what do I know? Anyway, any more questions? I think we're probably out of time. I'll be around all day if you got any questions. I love to talk about this stuff if you want to talk more offline.